Portfolio and Life Cycle, concept number 6 for DMLSS. The tools used to demonstrate the concept are not selected as the only solutions possible, but to illustrate what type of an ecosystem could develop in the next version of DMLSS once a services-oriented architecture is enabled. Other vendors are encouraged to demonstrate how their solutions fit into the DMLSS ecosystem. So our starting point for this particular proof of concept was a list of facilities for all the DMLSS servers and their locations. The data was redacted, so it's not the actual data, but it was an Excel file that was taken. And then to illustrate the point that this type of data, with the tools that are out there today, it's very easy to rapidly create functionality within a few minutes. So for example, a list in Excel of locations can be imported into a Google spreadsheet on the web, which then can geocode all the locations if they have, not even a full address, if they have a name of a city, for example, it'll put it on the map. If it has an address, it'll actually put it on that street address. The type of functionality that's pretty common nowadays with smartphones. People expect to be able to see the location on a map. And we found with our experience with other government agencies as well, this is not always an easy thing to do when you get a name of a facility or a project. So doing that as a first step to kind of start being able to visualize where in the world do we have facilities relating to healthcare. At the same time, if we look at the diagram with the little nodes on it, those are actual servers that serve the different DMLSS functionality for different locations in the world. So the blue are servers, the yellow dots are locations that rely on those servers. Those again were automatically created in Google Docs, Google Fusion tables, automatically to create this diagram. So the same data is kind of feeding into a map, feeding into a report, feeding into an input that you can actually edit the data, feeding into these diagrams and to charts in real time. This is about a 2-minute exercise to actually geocode and georeference these and get these charts going in these free applications on the web. From this application in Google, you can actually create APIs. So for example, you can give access to other applications to go and say, well, take a list of healthcare facilities and their square footage or the number of work orders, and let's build a widget that allows us to do something on an iPhone to do work orders, is one example. What we did with that is we actually connected it to the Onuma system. So we have Google Earth, Google Docs, Fusion Tables, the Onuma system now with the same data. We didn't have to re-enter it. We are actually using the same data that was processed, now geocoded within a few minutes in the Onuma system with dots on a map. And we focused on one location as an example. So we took building data for a naval facility in Japan just from a Google Earth map, public information, looking at the building footprints, created quick buildings and prototypes of a healthcare facility with DMLSS type of data embedded in it, and then viewed it again in Google Earth. So this is a mashup going back and forth between different tools, and then drilling all the way down into a building, into a floor of a building, into the layout of the floor, into a color-coded floor plan that shows condition of space or the floor finish as one example, and then seeing the actual layout of a room with the equipment, and then having a mobile application that was also connected to this that could read barcodes from a piece of furniture that could update information in the room. So this was created an actual functioning proof of concept for the DMLSS 4.0 vision of where this can go. And the starting point again was geocoding dots on a map that would be locations of facilities with BIMs in them, focusing in on one facility and then multiplying it out to, we took about 20 of them and actually just used Google Map and popped the map into position, connected it to that dot, so now it's live connected to Google Map and Google Earth images. And then once those were brought into the BIM application, in this case the Onuma system, we're starting to see reports. This is kind of a demonstration of what kind of live roll-ups we can do and say, well, give us an aggregated total of square footage or condition of space or operational cost or work orders, whatever it might be. It's all data. It's massive amounts of data, but it's just data. And data is a no-brainer as far as what's going on the internet. If you have structured data, which DMLSS does have, but making that structured data accessible in a web service format, obviously with the right credentials, you can get into and do roll-ups like this. And this is a functioning prototype of that, how that could work. In addition to that, we also focused on the one location at the naval facility in Yokosuka, Japan, a healthcare facility there. Not the actual floor plan, obviously, but it is similar to what a hospital might look like. A site plan, again, BIM, Google Earth, Google Map, Onuma system, Revit, database, floor plan, color coding the floor plan with the DMLSS type data, and then drilling down to an individual room if the BIM is available that shows the equipment in the room that's connected to an RPIE as one example. And then also looking at, okay, now that we have the system in CAFM, there's a lot of different types of uses for that. It's not just for managing equipment, but let's say for scheduling space. There are standards being developed on the web right now. For example, the OASIS Web Services Calendar, WS Calendar, led by Toby Considine, as far as structuring a standard for communicating about scheduling of spaces. So if you can schedule spaces and look at how rooms are being used and how equipment's being used, that's obviously of great value. The message here is that when you start getting these open standards connecting to each other, you start getting these tools that can start developing new functionality on top of the existing data without having to rebuild the whole system or rebuild a new tool. You're basically building a mashup on top of data that's already available. So with existing functionality that already exists on the internet, that already exists in these web applications, you're able to do things like this just right away. This is not a 5-year plan. This is something that can happen within a few days or a few months or however long, how much detail you want to put into it. And now we're drilling down to an individual room and looking at the patient schedule, whether it's what's today's schedule look like or what the projection is, which rooms are overcrowded or which rooms have capacity, and what's it going to look like 6 months down the line. So this is the one example of what would happen if you start managing the portfolio, connecting CAFM, CMMS, BIM, GIS, and DMLSS data in a format that is easy to use for the end user to be able to do things like scheduling.